Hi there. In this video, I'm going to explain to you how to answer a linear programming question that is asking you to describe an unshaded region. Okay, so in this video here, the question says, write the four inequalities. This means that there are four lines which are creating a boundary to a region R. So you are writing the four inequalities that define the unshaded region R in the diagram. Is that okay? So now what we do is we must identify each one of the four lines. Okay, we have to identify each one of the four lines and then work out its inequality. We work out its inequality. Okay, so the first line we are going to pick is this one here. You can pick any line of your choice. You can start with any line of your choice. But for me, I'll start with this one here. Okay, I'll start with this one here. So what I'm going to do is I'll ask myself, which axis is this line cutting? Is it cutting the x-axis or the y-axis? So we can clearly see that this line is actually cutting the y-axis at the point where y is 2. So since this line is only cutting the y-axis and it is parallel to the x-axis, I'll go ahead and say my first equation is y equals 2. You see that? Now I must change this. Why am I saying y equals 2? Because this line is cutting the y-axis at the point where y is 2. And any point you are going to pick on this line, the value of y will remain 2. Is that okay? So now let's change this equation into an inequality, because the question is looking for inequalities, not equations. So what we are going to do here is we're going to ask ourselves a question. Is R, this region here, is it on top of the line or under the line? So we can clearly see that R is actually on top here. You see that? So since R is on top, we need to understand that all numbers on top of 2 on the y-axis are greater than 2. All numbers on top of what? 2 on the y-axis. All numbers on top of 2 are greater than what? 2. So the values of y that we need, the R, are we together, is actually greater than what? 2. So here I'm just using greater than because my line is what? Dotted. If my line was solid, I was going to use a greater than or equal to. Okay, from this line we are done here. We pick another line. Let's go for this one here. Okay, let's go for that line there. So that line, I'll ask a question again. Is it cutting the y-axis or the x-axis? We can clearly see that this line is cutting the x-axis at the point where x is negative what? 2. And this line is also parallel to the y-axis. So meaning that the equation of this line is actually x. The equation of the line is x equals negative 2. That is the equation of the line. X equals negative 2. Wait a minute. How do we change this inequality, this equation, into an inequality? It's very simple. We just look at our region R. So let's look at our region R. Is it on the right side or on the left side of the line? We can agree that this thing is on the what? On the right side, right? It's on the right side of this line. So if it's on the right side of this line, we are going to notice that all numbers to the right of negative 2 are bigger than negative 2. All numbers to the right of negative 2 are greater than negative what? 2. So meaning that the values of x in R are greater than -2. All the values of R here are greater. So R is on the side where the greater numbers are. So we can go ahead and say x is greater or equal to -2. Now, why am I putting equal to here, greater or equal to? I'm putting greater or equal to here because my line here is not what? Dotted. If my line was dotted, I would have just put greater than. Okay? If this is okay, we proceed to the next line. Which line are we going to pick at now? So, we go for this one. That's the third line, right? That's the third line that is bounding the region R. So we go ahead and then we say the equation of the line. Look at it. At what value, which axis is this line cutting? Well, we agree that it's cutting the x-axis. Where is it cutting the x-axis? At the point where x is what? 4. So the equation of the line, number 3, is x equals 4. X equals what? 4. That is the equation of the line. Now, let's change that equation into an inequality. How do we do that? The question we ask ourselves is, if this line equals to 4, if on this line x is equals to 4, is the region R on the right side or is it on the left side? We can clearly see that the region is on the left side. You see that? So since it's on the left side, we know that all numbers to the left of 4, okay? All numbers to the left of 4 are less than 4, okay? All numbers to the left side of 4 are less than what? 4. They are less than 4. So if the numbers to the left side of 4 are less than 4 and our region is on the side of the less number, then we can conclude and say the x is less or equal to what? 4. So that is the third inequality. Okay? That is the third what? Inequality. We are saying the x that we need, or the region R, is less than this line here. It's on the left side of the line. And all numbers on the left side are less than. I really hope you've understood what we have done here. Let's go ahead and find the final line. The final line of this in this question is this line here, which is slanting like that. Okay? This line which is slanting here like that is our final line. Now, unlike all the other 3 lines that we have done, are you together? All the first 3 lines that we have done, you're going to notice that each one of them is either parallel to the x-axis or parallel to the y-axis. This one is not parallel to any of the axes. Okay? So you're going to notice that this line here cuts both the x-axis and the y-axis. So meaning that this line has a gradient. So for us to find the inequality of this line, we must first find the gradient. After finding the gradient, we must work our way through the equation of the line. Then that's when we can find the inequality. Without further ado, let's continue. Let's just go ahead and find our inequality. So the first thing we are going to do is pick 2 points on the line. Pick 2 points on the line. So there's this one, I'll pick this one, and that one there. Those are the only points that we are given in this question. So the first point here, this one is the coordinate 8, 0. Okay? It's a coordinate 8, 0. Then this one here is the coordinate 0, 6. This is the coordinate 0, 6. Okay, so now we're going to name our coordinates nicely there as x1, y1, x2, y2, like that. So it's important to name our points like that so that we can easily find our gradient. So this will help us to find our gradient. Please make sure that when you pick your point, bear in mind that on the x-axis, y is always 0. On the x-axis, y is always 0. That's why I've picked 8, 0. I'm saying on this point here, x is 8, y is 0. And on the y-axis, x is always 0. On the y-axis, x is always 0. That's why when picking this second point here, I've said x is 0, since this is the y-axis, then y is 6 there. I hope you get it. And make sure that every time you write a coordinate, you always start with the x value, then the y value. X, y. X, y. Okay? So let's go ahead and find our gradient. So our gradient, the formula is m equals y2 minus y1 over x2 minus x1. Is that okay? So if we substitute in this formula here, you'll notice that y2 is 6. So I have 6 minus y1 is 0 over x2 is 0 minus x1 is 8. So simplifying this here, we're going to have 6 minus 0 is 6. 0 minus 8 is negative 8. So if we find a number that can go into 6 and 8, you're going to notice that number is what? 2. So 2 into 6 is 3 over 2 into negative. So we'll have a negative there. 2 into 6 is 3. And 2 into 8 is what? 4. So meaning that our gradient is 3 over negative 3 over 4. Once we find our gradient, we can go ahead and find the equation of the line. So the equation of the line is found by the formula y minus y1 is equal to gradient x minus x1 there. You see that? So which one is our x1 and y1? They are here. This is our x1 and the y1. So it's easier to use those two values there. So where there's y, I just don't replace anything. I just leave the y like that. Minus, what is our y1? Our y1 is here. What is that number there? 0. So where there's y1, I put what in? 0 is equal to m represents the gradient. M is the gradient. So what did we find for our gradient? We found negative 3 over what? 4. So I do that. Where there's x, I leave the x minus x1. What is x1? You can clearly see that our x1 is what? 8. So here, where there's x1, I will put 8. I close my bracket like that. Let's go ahead and then simplify this. Y minus 0 is just y is equal to, let's distribute this. What is negative 3 over 4 times x? We get negative 3 over 4 x. You see that? Negative 3 over 4 times 8. So we get negative times negative is positive. 3 times 4, this is 24 over 4 there. Is that okay? So what I've done here is I've just multiplied negative 3 over 4 times negative 8. So since this is a fraction, I'll make this a fraction also. Negative times negative gives us a positive. 3 times 8, 24. 4 times 1, 4. So that's how you basically multiply your fractions. So that's how I came about, in case someone is wondering where the 24 over 4 is coming from. So if we simplify our equation, you're going to have y equals negative 3 over 4x plus, how many times does 4 go into 24? 4 into 24 goes how many times? 6 times. Okay? So that is the equation of the line. That is the equation of the line. But the question here is not asking us to find the equation. It's asking us to find the what? The inequality. You see that? So we go back to our we go back to our graph here and check where, since we have now y equals negative 3 over 4x plus 6, we go where this line is actually cutting the y-axis here. You see that? So the question we are asking ourselves is this region R under the line or on top of the line? So everyone can clearly see that the region is where? Under the line. So it's under. You see that? So since it's under, we know that all the numbers that are under 6, because here we have a 6, here the value of y is 6. So all the numbers that are under 6 on the y-axis are less than 6. All numbers under 6 on the y-axis are less than 6. Only those numbers that are on top are bigger than what? 6. So then we're just saying here, our y, we can now conclude and say, therefore, y is less than or equal to negative 3 over 4x plus 6. Okay? So this line here, this line here is the only line which is a bit involving. You have to find the gradient first. After that, you have to find the equation of the line using this formula there. After that, once you find the equation of the line, which is this equation that we have found here, you can go ahead and change the equation into an inequality. I hope this video has helped you in some way. I'm positive that you are going to benefit. If you are sitting for a GC exam, if you are writing a grade 12 exam, you are preparing for a mock exam, I'm very positive that this video can help you with linear programming. Thank you so much for watching this video. Please consider liking this video, subscribe to this channel. To your like, your subscription will be very much helpful to the growth of this channel. Consider sharing if you know someone who may be interested in still struggling with linear programming. If you have a question, you can just drop your question in the comment section. I am going to surely help you. Thank you so much for watching. Until next time, bye bye.